Hello students, so we are going to see that the derivative of such functions which are given in some parameter and those parametric forms, how to find out their derivative. So we are going to discuss today with some interesting examples. So let's move on that. Okay, so let's understand first what is parametric equation. X and y, where they are the main variable up to now, which you have seen in various questions. Now a third variable t is going to be present on which your x and y is dependent. So here y is also the function of t and x is also the function of t, so that here t is going to be associating x and y both. How x is associated with y? You can understand in this way, that since t can be written as inverse function of x, and if we substitute this value of t in this function, so we get the y is equal to function of phi x. That means y is associated with x through this way. So here t is the parameter which is connecting x and y. So t is going to be also available in the answer, because your x and y both function are present in t. So your answer which will be getting here, differentiating y with respect to x, that will be also present in terms of t only. Okay, so let's see some of the procedure how to find out the derivative of parametric equations. So whenever you have to calculate the dy by dx with respect to given parametric equations, so here dy by dt and dt by dx we can write for the dy by dx by chain rule. So this dy by dt you leave as it is. This dt upon dx you can write as reciprocal of dx upon dt, and then this thing you can write dy by dt upon dx upon dt. That means you are getting the expression where we are differentiating y with respect to t and we are differentiating x with respect to t. That means x and y both function will be differentiated with respect to t, and then we take their ratio, so then it is going to give us dy by dx. So let's see some more example, some interesting example which will make you clear that how to find out dy by dx for parametric equations. Okay, so let's take one example here to show that how a pair of parametric equations can be chosen for the purpose of dy by dx, and with the help of these two equations how we obtain dy by dx. And this question has been asked in CBSE 2003, and many such questions are going to come in your board exams also, where you can easily find out the derivative dy by dx with the help of these two equations. So because you can see that here both equation has the variable theta, that means theta is the parameter here in which both equations are expressed. So we have to differentiate equation first also with respect to theta and equation second also with respect to theta. So let's differentiate first equation of y with respect to x. So what we will be getting, dy by d theta, this will give us a is a constant which will come out, so dy by dx, dy by d theta sine theta and minus d by d theta of theta times cos theta. Okay, now you simplify it further, so you'll be getting it, sine theta derivative will be giving you cos theta, and here theta into cos theta derivative is going to be calculated with the help of product rule, which will give us theta into cos theta derivative will be minus sine theta and plus cos theta, and derivative of theta with respect to theta will be 1. So finally what it is coming? It is coming a times this bracket when you open, so you will be getting cos theta minus, and that cos theta will be cancelled with this cos theta. So ultimately we are having left with minus times theta. This minus minus ultimately becomes plus theta times sine theta. Okay, so we have got a theta sine theta as derivative of y with respect to theta. Similarly, we are also going to calculate the derivative of x with respect to theta. So let's see. So x is given a times cos theta plus theta into sine theta, and we have to differentiate with respect to theta. So differentiating with respect to theta, we get dx d theta. A will be out of the derivative as a constant, so here d by d theta of cos theta plus d by d theta of theta times sine theta. Okay, now differentiate this right hand side component. So cos theta derivative will be your minus sine theta, and plus this will be find out with the product rule. So derivative of this is going to give you theta sine theta derivative will be cos theta plus sine theta, and derivative of theta will be 1. So after simplification, what we get here, this minus sine theta will be cancelled with this sine theta after opening the bracket, so you will be left with only theta times cos theta. Finally we are getting a theta cos theta as the result of dx by d theta. Okay, so this is the equation second, we can say. Equation fourth, because third is this one, previous equation. So your equation third is giving the value of dy by d theta, that means the derivative of y with respect to theta, and equation fourth is giving the derivative of x with respect to theta. We have to find out dy by dx. So how to find out dy by dx? We have seen that in parametric form, whenever we have to find out dy by dx, so y with respect to theta value has to be taken ratio with x derivative with respect to theta. So here dy by d theta and dx by d theta, we substitute the values from equation third and fourth. So equation third is giving dy by d theta value a theta sine theta, and here we are getting the value as a theta cos theta. So a theta get cancelled, and finally you are going to get here as tan theta as the answer.